through and looking at the different solutions that our interns have been working on. Of course, we do have this program running every quarter in our countries that we have our presence in, here in Kenya, Uganda, and Tanzania. And through these sessions, we do have placements from the education sector, but also from the practicing professions who join the program, and they're able to learn on the technology application in different industries. For instance, looking at today's program, we're going to have our interns looking at the ArcGIS technology benefits and application in smart city design and planning. We are looking at modernizing parking space and management, public health preparedness, and land administration workflows. So all these should be able to give you an insight on what are the benefits of this technology. How can we bring value and make this technology work for you? So for this session, I would like to just be brief and welcome Claire Kaija from Uganda to start us off. So Claire, if you're ready, you can begin. Claire Kaija, once you're ready, you can share your screen and start us off. Thank you. So as Claire prepares, we're just going to have the next presenter come in as Claire prepares her machine. So Chelsea, if you're ready, please proceed. Thank you.
Good morning, everybody. Good morning, everybody. My name is Chelsea Otieno. I am a fifth year geospatial engineering student from the University of Nairobi, and I have had the privilege of doing my attachment here at Esri for the past 3 months. It has truly been an eye-opening, a learning experience, as well as an enriching experience, since from that time, I have been able to put into practice all the GIS theory that I've been learning in school. I would like to extend my gratitude to the entire SG Eastern African team, particularly Joyce Yundu and Maxwell Majuek for their mentorship during this program, as they were very instrumental in guiding me to bringing my solution to life. My solution is on modernizing parking space management with ArcGIS, and I will get straight right into it. I have named my solution Spot Your Spot Stress Free. In this case, the spot refers to the parking spot. I would like you to imagine this, which is a situation most of us have experienced. You are driving around a parking lot when you finally spot a free spot, but just as you make your way to the free spot, another driver beats you to it. This is a common experience you have at parking lots. In Kenyan malls, particularly in shopping centers, the vehicles that are manually searching for free parking spots account for about 40% of the traffic, which results in traffic congestion for both the incoming and outgoing vehicles and also affects the customer experience. As you can see there, this is a frustrated driver due to parking issues. So how then can we solve this solution with ArcGIS? With the ArcGIS system, organizations, malls, shopping centers, different corporations can develop a modern parking management system that will improve the user experience, operational efficiency of the mall, and also in turn improve revenue generation for the mall. The main objective of my solution is to enable optimization of available space and enhance traffic flow in a mall's parking lot, with the specific objectives being to be able to real track traffic flow in real time, as well as locate free parking slots in real time and provide this information to the users so that they can navigate faster and have a better experience navigating to free parking slots, reducing the manual process of doing so. For my solution architecture, this is how I have used the ArcGIS system to be able to come up with my solution. Firstly, I was able to do data collection from various sources such as satellite imagery, tabular records, data from sensors, and then storing all this data in a geodatabase, where after that I now moved on to the data analysis and management aspect, where I did this on ArcGIS Pro, where I was able to use all the data that I had collected, all the tabular records, satellite imagery and sensors, to perform analysis and also for mapping of the parking layout. From there, I was able to come up with an output, one that would serve users for public access, that is for mall users. Using the ArcGIS Experience Builder, I was able to develop an app that would enable the users to navigate to free parking slots. I was also able to come up with a dashboard, which would be very useful to the managerial board of the mall. These are people like the marketing manager, the finance manager, and the general manager. It will help them in making planning and decision making, since a dashboard enables visualization of several insights, for example, revenue generated and things like the peak hour of parking for the mall. The most important aspect of a modern parking space management system is the real-time parking space monitoring and location, which would definitely require location data. With Internet of Things sensors, malls and organizations can be able to track free parking spots in real time and use this data to help the customers navigate to free parking slots, enhancing their experience. But how exactly would they do this? In this instance, I'd like us to optimize the parking lot for a mall. This mall, I have named it Giraffe Mall. A little background about the mall is that it is a mall that is located in Nairobi City, so it serves about 2,000 shoppers daily, and its parking lot has a capacity of 298 cars. So how then can Giraffe Mall optimize the use of its parking space? The first thing would be parking segmentation to allow users to serve the different demographic of shoppers they have in the mall and also enhance traffic flow. For instance, you can see the K slots here. These are slots that have been reserved for a particular demographic, which is people that are living with disabilities. We also have, for my case for the Giraffe Mall, it has a playground adjacent to the parking center. So for the slots labeled in H and J, these are slots that have been segmented and are recommended for users who would like to visit the playground to enhance traffic flow. Now let's get into the ArcGIS system. What's next after segmentation? How do you now do the real-time tracking of the free parking slots? This is where the ArcGIS system comes in. First, the ArcGIS system is meant to serve the mall user. The mall user has two questions or two needs they need to be served. One, how do I identify a free parking spot? And two, how do I navigate there easily? For that, I was able to, using the ArcGIS Experience Builder, I was able to create a user app that enables mall shoppers to navigate to free parking slots. And I will demonstrate how this works. So here, firstly, when the user logs into the app, they will answer a few questions such as, what is the purpose of your visit? Are you coming here to visit the mall? Or are you coming here specifically for the playground? Or is it a combination of both? Nextly, to also enable the management understand the different types of demographics and cater to their accessibility needs, there's a question on, are you an elderly person? Are you a person living with disability? Or are you none of the above? Here, there's also a question on the estimated duration of stay. So when you log into the app, you can select, are you estimating stay here for less than an hour or 1 to 3 hours or 3 hours, so that you can recommend parking slots according to that. Then finally here, they will be able to see all the parking slots that are free. As you can see, these are the parking slots that are free from here. So for instance, we say our user selects F30. Here we also have, the next aspect of the app is we have the parking layout map, where they can be able to now navigate to the exact parking slot after seeing that it is empty or occupied. As you can see here, the parking slots that have been labeled in blue are occupied, whereas the ones that have a yellow goldish color are empty. So for here, in this case, we have F30. The mall user can click on that, and then they'll be able to see information that this is for a regular user, so they are okay. This parking slot is F30 and it is empty, so they are free to navigate to that parking slot. In case they had selected F29, they can be able to see that that parking slot is occupied, and therefore they will not be able to navigate to that particular parking slot. All this is happening at the entrance. They have not gotten to the entrance of the mall. They have not, the entrance of the gate to the mall, sorry. They have not yet gotten to the parking lot. So the user is here. So from there, they'll be able to input the location of the entrance of the mall, which is there. And then for this user, they wanted to navigate to the empty parking slot F30. So they will come here. As you can see, the app there directs them to the exact parking slot of F30. So they do not need to go through the hustle and bustle of going to the parking lot and manually searching for a free parking slot, because thanks to this app, developed with ArcGIS Experience Builder. It has shown them the route and also estimated the time that it will take for them to take there. So for instance, in this case, it will take our user 3 minutes and they'll cover a distance of 627 meters. Firstly, from the gate, they'll be able to go northeast, they will be able to turn left and then turn right. This is the recommended fastest route for this user to navigate to the desired parking slot here, which is F30. Nextly, we have the ArcGIS system for the managerial body. For this, I was able to develop an operational dashboard that serves both the parking operators, the people in charge of managing the operations of the parking, as well as the senior management, the executive management. This dashboard will enable them to make decisions on traffic flow and also inform strategic decisions, as I am about to explain in the next few seconds. Here is the dashboard, the operational dashboard. The purpose of this dashboard is to enable visualization of insights such as revenue generation and even peak hours. Firstly, as you can see here, it shows that this widget shows the number of parking spaces available in this parking slot, which are 298. And then from this pie chart here, you can be able to tell from the overall parking capacity of 298 vehicles, how many slots are occupied. You can see it informs the operations team that we have 227 occupied slots. And you can also see here empty. You can see here it is informing the operations team that at this particular moment there are 71 parking slots available. And then just the same way the mall users or slash shoppers are able to see the exact empty and occupied slots, the operations team are also able to see, since the blue represents the occupied slots and the yellow goldish represents the empty slots. I was also able to add a widget for a serial graph. As you can see here, this shows the number of vehicles and the parking charges. For different malls, charges are done by the hour or they increase hourly. So for instance, for this mall, for 0 to 1 hour, vehicles pay a parking fee of 50 shillings. For 1 to 2 hours, a parking fee of 100 shillings. For 2 to 3 hours, a parking fee of 150. And for more than 3 hours, 200 shillings. So you can see from here, this can enable the management to see that most of their users actually stay in the mall for 2 to 3 hours. And you can see that we have 19 vehicles that paid 150 shillings as compared to 9 vehicles that paid 200 shillings, showing that more vehicles are here for 2 to 3 hours. And you can see how this revenue contributes to the total parking revenue. For example, you can see if you click here, you can see that then the 2 cars that were here for that paid a parking fee of 100 shillings contributed to 7,000 of the total parking revenue. This gauge here shows companies set different targets. So for example, this Giraffe Mall have a target of 40,000 of earning 40,000 from the parking every single day. You can see that from here they can be able to track how they're performing according to their targets. Here they can see on this particular day, they were able to, or at this particular time, they have been able to generate 37,200 Kenya shillings, which falls a little bit shy of their target of 40,000. On the dashboard, we also have vehicle details. These are details that are private and can only be seen by the operations and management team. They can be able to track exactly which vehicle, here we have the number plate details, which vehicle came in at what time, left at what time, what was the parking charge that they paid for different vehicles. You can see here we have a different vehicle that came in at 1:20 p.m., left at 3:06, and it was parked at D11. You can see here we have data for KBX here, 512E. It came in at 1:40 p.m. in the afternoon, and it left at 3:02, paying a parking charge of 100 shillings. So this, they can be able to track the details of their different customers. And also for security purposes, in case there's a problem with the parking spot, they can be able to identify exactly which car was at that parking spot, at what time, the duration, and the particular parking spot. There are many benefits to using ArcGIS to modernize parking space management, such as enabling real-time monitoring of parking availability, as I have demonstrated, for operational efficiency and efficient route guidance for drivers, which enhances traffic flow in and out of the mall, as well as improving the general user experience. That is the end of my presentation. Thank you. I would like to invite my colleague Claire Kaija from the Uganda team to present her solution.
Hello, everyone. My name is Claire Kaija. I'm a land surveyor who has just recently graduated from Makerere University with a bachelor's degree in land surveying and geomatics. And I am happy to have been part of this internship. And during the last 3 months, I've been able to have an opportunity to enhance my GIS skills, master the S3, the different S3 softwares and platforms, and also learn how to model business solution with GIS concepts. And also putting that aside, I've also been able to build some good friendships and rapport with the people back at my office. So allow me to take you through my project, which is the ArcGIS for land administration and production mapping, an innovative GIS solution for effective land management and production. Introduction. So, with the rapidly growing population today, there is an inevitable increase in land parcel transactions. Now, for us to be able to benefit from this large volume of parcel transactions, there should be an effective parcel management system in order to achieve well-developed and organized cities. My problem statement is that currently the current land administration systems suffer from fragmented data storage and lack of topological integrity. Topological integrity includes things like parcel overlaps, land parcels overlapping each other, and then also maybe parcel lines extending even beyond the parcel. Now, this is a very dangerous thing because it brings about increased land disputes, and also people lose trust in the land administration systems. Additionally, most of our land administration systems, stakeholders also struggle to get up-to-date parcel information to use in land transactions and other processes. You find that the government jealously guards this land information, yet people have to be able to access a certain bit of information to be able to go about with certain land transactions. So with this is why I'm proposing the Parcel Fabric tool in ArcGIS. which provides a comprehensive parcel management system with seamless editing, topological integrity, historical tracking of the changes, and sharing of the land information data. My objectives are to develop a comprehensive and easy-to-use land database, and then to make land information easily accessible for effective decision-making. Solution architecture for the project. We need best data for this land administration system. And the best data will be either from satellite image, digitizing of satellite imagery, or field data collected by surveyors, which is first put into a CAD software. And after a CAD software, that's when we can put it in our ArcGIS environment, ArcGIS Pro. And when we have those base parcels that we've either digitized or from the CAD software, we can be able to build a parcel fabric, which is this in the next step from those parcels. Now, remember, those parcels also have attribute information attached to it, like the owner's name, the parcel ID, the parcel area, and all other attributes that go on land parcels. So with the parcel fabric and that attribute information, we can be able to build our land inventory database, which is our first main product. Now, in addition to that, you can be able to add data from other government databases like access roads and zoning, so that we can have a comprehensive land database as our objective one stated. So when we have our land inventory database, from it, we can be able to build even more products that help in stakeholder engagement. Things like title maps, a land transaction app that can be like a way of communicating between the public and the land ministry or office in case someone wants to effect a transaction, and then web maps for people to be able to access some land information, and also a dashboard, which I call the land information manager, for people to be able to search for their land parcels and get also land information. So why the parcel fabric tool in ArcGIS is because of topological integrity. Now, when you have a parcel fabric, spatial relationships are maintained when parcel features are moved or rotated. So whenever I move a parcel, it goes along with its geometry, the points, and the lines that make up the parcel. And then also there's a records polygon feature class. And this feature class helps us to store legal document information about the parcels. Things like when was it created, who created the parcel, maybe who subdivided this parcel, and so on. And when was it created, when was it updated? Yeah. And then also there's the parcel fabric tool enables us to keep historic parcels. Historic parcels are basically like mother parcels, like original parcels from which new parcels are made. So that information is also available in our parcel fabric. And these historic parcels, they're aligned with current parcels, so they overlay in exactly the same place, just that the appropriate boundaries can be retired. The old boundaries are retired in the parcel fabric. Then there's also parcel lineage, where parcels are associated to the record that created them and retired them. So you can be able to view this parcel came from this mother parcel and it was retired by this, etc. Now, also, as I said, the parcel polygon geometry. The parcels, each parcel will have boundary lines. That's for line geometry, and then connection lines and points. Points help with location on ground. They'll have coordinates, so you can be able to locate that parcel on ground. And also another good feature in parcel fabric is that a single parcel can easily be isolated and viewed alone. Yeah. And then also there's flexible parcel editing. You can be able to merge parcels, you can be able to subdivide, you can be able to do new surveys using traverses and so on. And lastly, there is also quality management. So quality management can be enforced through rules to be able to enforce topological integrity or to be able to enforce parcel type rules, etc. And this quality can be monitored through error functions. So if a parcel is deviating from the rule, there will be an error you can notice. So with that, I'd like to take you to my first product, which is the land inventory database in ArcGIS Pro. And so I want to explain some of the rules, some of the good things about the parcel fabric. As I said, the first one was topological integrity. So when I try to move this parcel, you can see that it moves with its line geometry and its points, which is a good factor. Yeah, so meaning whenever I move a parcel, its geometry is still maintained because ideally the geometry shouldn't change if you're moving something. And then we talked about the records polygon feature class storing information which can be gotten from our attribute table. So if we can be able to view who created this parcel, when was it created, so the record type, was it a split, was it a merge, was it a subdivision, and then the recorded date, you can be able to see when this record was created and then created by, and also the historical parcels. We want to know that what are the mother parcels of some of the new parcels we have. So when I turn on this historic, this shaded area, the hatched area is shows the historic parcels, meaning to create parcel 407, I merged these two parcels. So those are the mother parcels of this. And also this was one parcel, but then I subdivided it. So meaning this parcel below is the mother parcel of these two parcels, which is a good thing for us to be able, in case of legal tracking or disputes. Yeah. And then another thing that is good in the parcel fabric is that you can be able to merge and subdivide. And also I said we can be able to separate a parcel and view it alone, which is this. So in case you're doing analysis or you're providing data to some organization, can be able to single out that parcel with its information and be able to share it. So my second product, apart from the land database, the comprehensive database, and the red lines are the access roads. As you can see, Chiwenda Road, Serika. So we can be able to integrate other data sets into this parcel fabric. It's very possible. So my second product was a title map. As you know, this is proof of ownership. So you can be able to create title maps with this as a subject plot and maybe showing some nearby plots around and showing the line geometry and parcel number, the area, and the points for the parcel corners so that someone can be able to locate their parcel on ground. And we can have stamps here by the cartographer or registrar, and also showing where the parcel is located, Wachiso district, Maokota block, and the plot number. Yeah. So for stakeholder engagement, that's the first product, the title map. The next is a web map, which can be accessed online. If someone this land, the person number, what boundaries on this land. Yes. And on top of that, there are some charts for analysis of all that data, parcel data. So there's a bar chart showing parcel ownership by gender. So in case you want to know how many females are owning land or how many males are owning land, we can be able to get this information from our web map. And also, if you want to know the number of people how people hold land, like the different a bar chart showing count by land tenure type, how many people hold freehold land, leasehold, milo, private, milo, etc. So this also enables people to access this information easily in case they want to do maybe analysis or research. Then my next product is the Land Information Manager, which is a dashboard. Now, the good thing about the dashboard is you don't have to take a long time searching for a certain parcel. If you want to get the parcel information, you can just be able to. It's also generally showing the different parcels. In case you know the block number, in case you want to buy land, you know the block number, parcel number, but you want to be able to, as if prove that the owner is telling you the right information about the land. You can come here, select the block number until which land is, and then select the parcel ID. When you select this block number, only the parcels in that block will appear. So maybe 603. And it will zoom to that parcel and provide you the information easily. Like who owns the land, encumbrances, gender, age, and this information just facilitates your transaction, just helps you maybe confirm that this person is selling you the truth, the land is theirs, it's in their names, and you know that you're buying the right thing. So on top of that, there's some general analysis about the land information, tenure ownership of land, and also maybe the summary of encumbrances on land parcels for maybe government, etc. And lastly, the land transaction app is also another product that is possible with my project land administration using ArcGIS. So this form is just like a communication between the public and the lands ministry, so that you can be able to effect a certain transaction, sell, subdivision, etc., so that it's done in the parcel fabric and then feedback is given back to you. So a sample, let's fill out a sample form, put in the date which you're requesting, like the owner name, maybe Paul, block 3, provide your email address, your phone number, national ID, the parcel number, the land size, and then you give us an approximate location of the land. Then these are transaction details. What type of transaction do you want to do? Is it a title transfer, a merge, a subdivision, boundary adjustment, new survey, change of particulars like change of land use, etc. So you can click on transfer of land and where wanting to transfer land, maybe you're selling. Then is it related to other parties? Yes, because you're selling to another person. Names of other parties, maybe Valeria. Then supporting documentation could be something like maybe a deed, that an agreement between you two, or it can be a surveyor's report confirming that they have done a survey and maybe and so on. So maybe you put a PDF, and then what's a preferred communication, what you want to receive updates on your request. Email, can put also SMS. Then any additional information you want to include, and then a declaration where you can sign. And then when you submit the form, the ministry, we can connect this submitting of the request to the ministry portal using Power Automate, so that when you submit the request, they can be able to get an email on their portal to know that you've gotten the request. They have gotten the request and they are working on it. Yeah, so basically that comes to the close of my project. And by using ArcGIS for land administration, using the Parcel Fabric tool, land administrators can be able to improve accuracy, transparency, and decision making. And we can be able to come up with smart and organized cities, because development starts from the land. Thank you for joining in. I'd like to introduce the next presenter to take you through their project.
Good morning, everyone. My name is Willie Kiambuthi. I'm a fifth-year student at Jomo Kenyatta University, studying electronic and computer engineering. I've been an intern at Esri Eastern Africa for the last 3 months, and I have a project that involved ArcGIS, use of ArcGIS for port operations. Yeah, so today I'll be presenting the Stormwater Utility Network project, which aims to improve Mombasa City's stormwater management system. And the primary goals of this project are to reduce flooding and ensure that stormwater infrastructure can handle current and future demands effectively. So Mombasa Port has grown to become East Africa's largest and busiest seaport. Its low-lying location makes it vulnerable to flooding, worsened by poor drainage and climate change. Rapid urbanization also increases runoff and also causes outdated stormwater systems. So Mombasa Port location makes it vulnerable to flooding. It's also worsened by change in climate and the poor drainage present there. Due to increased runoff, overwhelmingly outdated stormwater systems, and also the communities around there are not able to adopt sustainable solutions to prevent flooding risks. So I'll be using the stormwater utility network provided by ArcGIS to analyze the stormwater infrastructure currently there and also identify gaps and bottlenecks. So my objective is to evaluate the effectiveness of existing stormwater drainage systems in Mombasa Port and surrounding areas, and also establish a systematic approach for monitoring and maintaining stormwater infrastructure to prevent blockages, and inefficiencies. So this is my solution architecture. We start with the data that is in your PC, which includes the data model for the stormwater utility network provided by Esri. When you put it to ArcGIS Pro, now you can involve the web maps. You have the ArcGIS field maps. And then you can also involve the ArcGIS dashboard, that can help you in the inventory of the infrastructure. And we also have the field maps that will be used in the field operations and inspections. So the solution architecture integrates GIS technology, real-time monitoring, and sustainable drainage systems to optimize Mombasa's stormwater management and reduce flooding. Okay, a minute. So have this. Just a minute. So when you open your field maps, you'll be taken to a survey question, the survey 1 to 3, where as an inspector, you'll be able to fill in your details like your name, your inspector ID, your department company, and you also have the date of inspection and the time. And we also have the condition of infrastructure. So if we can try filling in. Inspector ID. You can put in the inspection details that you found there, if it's leaves, trash, or sediment, or other. You can also describe other here. You can also say something like broken pipe. So maintenance is required. You can estimate the cost of repairs in Kenya shillings and upload a picture if you have. Then you can submit. After submitting, just a minute. I'm trying to get out of the full screen. Oh, okay. So that you go to the details, the data details provided by the survey 1 to 3. You have the details that you can refresh this. So yeah, you can see we have the form that we filled. So this is seen by the admin that helps notify of any changes in the stormwater network. You can also go to your field maps. Here you can on your phone you can when you reach the Mombasa area, there's a notification that will be sent because of activated geofence. It will ask you to complete that survey and give you this map of the stormwater around Mombasa. So when you are inspecting, you can, let's say, go to this pump. So it's made, you can confirm it's made of stainless steel. The pipe is submersible pump. And you can also, if it's not in good operation conditions, you can write either offline or standby. Then you can update. You can also do that for the manholes, the pipes, the apron outlets, the oh, okay. You're able also to edit details about the manholes like this one. You can inspect it, and when you find maybe, let's say, trash or sediment, you can just go to your field map, click edit, the inspection time. It's okay. And if it's not in service, you can write decommissioned. Then you can update it. So this data normally goes to the ArcGIS dashboard, where you can see the details of the infrastructure that you just updated. Just a minute, it loads. In the meantime, you can also, like this is an apron outlet. Also pipe outlet, yeah. You can also say, okay, you can also inspect it and confirm if it's in service or not. So the ArcGIS dashboards, they're the ones that help you analyze the inventory of the infrastructure of the stormwater network. The manholes that we've added, the data is already in the dashboard. We have 4% of them that have been deformed, 1.33 that have been decommissioned, and 94% are working. We also have the number of functioning pipes and the pipe status. The few we've done, we've seen 0.78 of them are under maintenance, and the 0.78 of them are out of service. You can also see the details about the pump operating conditions. If a pump is in service, if it's standby, or if it is offline. So the benefits of this will be to enhance efficient water flow management. The ArcGIS-based storm drain system ensures that stormwater is effectively captured, stored, and diverted, preventing water accumulation in critical operation areas of the port. It also helps in asset tracking and maintenance. ArcGIS allows for precise mapping and tracking of all stormwater assets, such as pipes and catch basins, making it easy to monitor their condition and schedule timely maintenance. So in conclusion, the project aims to significantly improve the city's drainage and reduce flooding risks, and also enhance the resilience of urban areas. By implementing sustainable solutions and advanced technologies, the project not only addresses immediate stormwater challenges, but also promotes long-term environmental and urban development benefits for the region. Effective stakeholder collaboration and modern tools like ArcGIS field maps will ensure efficient use of the stormwater utility network. With that, I would like to welcome my good friend, Donatas Mkambat.
Thank you, Will, for welcoming me. My name is Donatas Mkambat. I'm the final year student at Yale University, pursuing Bachelor of Geographic Information and Remote Sensing. But I've been currently completing a 3 internship math period at EISL, currently based in Dar es Salaam. In that period of 3 months, I'd been working with a project titled Effective Billing and a Payment Solution for the Water Utilities. So here I'm trying to present before you on the working flow of my project from the meanwhile until the end of where I've been working of. In my PowerPoint presentation here, you can see the heading and the title of my project, as I have recommended before, that it is an effective billing and a payment solution for water utilities. All of this involve application of GIS technology in a building and a payment solution for water utilities. That's why we have implemented and see how our GIS solution knowledge, and again that I've gained here for all 3 months, how can be beneficial to bring out solution in solving various problems that are facing various utilities. So in order to be hand by hand, so each and everyone can be aware of this project, I would like first to explain the title of the project. What is it concern? Whenever we say that an effective means an improvement that enhances transparency in all of our working matters. So now through using that GIS technology, we'll bring an overall solution for that will improve both the financial performance and the water utility services that will be provided to the community. But also this title definition can be explained in form as a system. This integrate the system that will be efficiently for the managers to process the billing of the customers for their water usage through correcting the payments that will be done by the customers. Without more further delay, I would like to move on the introduction part, where I will explain the main goal of this project in finding out solution in solving various problems concerning for the utility managers as well as the customers. So the main overview goal for this project, it will emphasize on bringing improvement on financial performance for the water utility. Also will be beneficial for the customers as well. So as each and everyone can be aware of this to be done, I've demonstrated a short illustration that shows from the beginning until the end on how the customer will be able to access such services, and also on how the utility managers and the various companies will be able to customize the services. This shows the demonstration of the customer to make the payment on the bills that he or she is supposed to acquire. To demonstrate the platform where it may use a mobile phone or personal laptop or whenever it's desktop, and will make registration of the system, as also will be able to utilize all the services that will be provided by the customers. Furthermore, I will describe the problem that have been led to this. This, as we know that specifically in Tanzania, as my case study, it has been facing a lot of growing operational challenges and inefficiency in the billing and the paying system. This has been remaining a significant barrier to both the customer satisfaction and sustainability. It brings up challenges such as delay in responding to customer to get the required services due to poor spatial tracking. Find that the customer has been requested to a particular month period of the time, but you find that such request payment number is brought to him or her after like 2 or 3 days. So the rate in responding to tracking set on the bill number bring up such challenge to the customer and make such complaints. Also, there is an accessibility of integrating the customer billing information and the physical network. This is due to poor portrayals of the system that have been made by the utility companies. You make it very, very difficult for that customers to access the required services. Also, there is a problem in limited customer service where there is a lack of real-time information about the customer accounts and services. All of this, we're going to see how can be addressed and how can be solved. Without more further delay, here now is the objectives on this shows how this is going to be handled to be solved. It's just through implementing the GIS technology to accurately map water infrastructure and the customer location. Whenever we develop and implement an efficient GIS-based billing and payment solution, we try out the needs of the water utilities, more specifically in Tanzania. So here there is a deployed development services that will show on how customer can access those services. That involves the user-friendly billing environment platform that will be integrated with the customer information for making it easier optimization for water distribution through data-driven decision-making. This is the undertaking of objective that will bring out the significance of our project. The significance of the project is based both to the customers, also to the utility companies. You can see how the customers will be beneficial to the project. Also, we shall see how customers or utility companies will be beneficial to the project. On this total map, I explain how the customers will be beneficial to this project by providing accurate meter reading that will involve accurate meter reading for the specified time and payment method that have been included. It shows that the cubic meter have been used to calculate the usage on the water account and the leak detection. They're also being shown in the measurement for every meter that have been deployed. On case to the utility companies, they will enhance and reduce the non-revenue water through implementing leak detection and the prevention and measurement. Whenever we are talking about non-revenue water, those water that will flow out without any intervention in measuring, why they are not controlled in the system. The non-revenue water that we are talking about are this one that you can see here. You can find throughout the system operation and the infrastructure that have been made by the water utility managers. They have been got the leakage and those water flow out is and without any flow control that will affect the utility managers to get loss and they will make them in the revenue loss. So now here for the expected output that we are going to get, involve a GIS-based platform monitoring, where we'll have an interactive dashboard that will display key performance indicators and the billing statistics. This dashboard is just for monitoring. Also, we'll have the customer portal user-friendly web application and real-time update. We shall see how this will be applicable in this. These are just a few illustration tools that have been integrating them throughout this project. The ArcGIS Pro, the manual one source, will be used for mapping spatial analysis and the visualization for water utilities infrastructure. Also, I've been deployed it or the working environment database structure, geofile geodatabase, and so further, etc. Map of your CRASC, survey 123, ArcGIS Pro dashboard workforce. For deploying web system application, I've used just MySQL. You shall see of working background of the work that from the beginning in integrating with for MySQL. Also for IntelliJ, I've been integrating the database. Yeah, let's see the deliverables that have been formed out. Here's my solution architecture flow diagram that shows the working methodology from the beginning up to the end. For stakeholder engagement, that was essential for providing charters for both administrative users and the customer for efficiently for the data collected. But for customer service portal, this was for easy interaction with just billing system information. That the water utility billing and the payment portal, it saved at the central platform for handling transaction, as it was accessible through multiple channels such as API, web, devices, and furthermore, etc. But the authorization and security that ensures sensitive data is very accessible and processed only in the authorized users, only for that. My case study area of interest displays that I'm found in Tanzania, where that it has the Dar es Salaam region that have been categorized to different districts. From there, my case study operating working for the project was DAWASA, that's found in Makongo. I used ArcGIS for utilizing for data visualization, as I have shown you here before. This was my working interface. The blue color line shows distribution of the pipe network toward the customers. And each one have been utilized with a centralized system from where water comes from the main pumping station and attributes to the pipes until the required user. The mode operation getting this data, I use the digitization method that not to get less of getting the real data from the particular organization, that's DAWASA. So that digitize them, then I displayed them as they can be shown here. And I use the survey 123 for essential customer data information collection. On clicking the link shown the PowerPoint, you direct me to the survey 123 form that can collect data, and somebody can write his name, activity that, and all required necessary data that a particular utility company to collect. For instance, water utility net account number, contact phone number, email address, and for further, etc. MySQL database working interface and integration of IntelliJ for creating a web system. Also, here the statistical information that shows the weekly data for the information that were collected from the survey form. That was shown. Unfortunately, the internet is so weak, it cannot open the spot. Without more further delay, there is a task assignment for the workers. Because the whole system needs maintenance and the capacity, we have to assign tasks for the several workers so as can be utilized for each one having a specific task. I can see the number of assigned, the one who are not on working, the one who are on break, the one who have not assigned, those who are in progress, and those who are completed the work. So the monitoring can be done in all means and all specified action that duty managers is needing of them to do so. The one that I've shown is weekly statistical data that shows statistics of the data collected from September 5 up to September 17, 2024. This is the map of viewer that shows my study area and the extent of where my project concerned. The number of customers being distributed, the area boundary, that's Makongo. And they also specified the number of 67 have been deployed within all of this area. Here below the average billing amount with the respect of the payment method. It shows the specific payment method a certain customer will use in deploying in order to get services in the billing information. There's a mobile, cash money, bank money, transfer, and the statistical method that shows sum of current billing amount with respect to the payment method. Before conclusion, I will state on the few demonstration of my dashboard that explain the notification status that a particular customer will be given whenever his or her bill is an over. The statistics show that most of the 33% have already been notified. And the same likewise, notification status has been failed, but you can also transform and know the one who have been sent by utilizing the billing site interactive. Also those who have not yet been paid. Also the payment status for a particular customer, can see the one who have been paid and the one who have not yet been paid. Overdue will be shown here, and those who have paid also will be shown here. Also, the meter status regarding a particular customer has an issue or not one. Meter status for those customers who have been, whom their meter status are operating are those one, and those one whose meter status have not been working, those are faults, are these ones that have been displayed here. The current meter reading for a particular customer, a particular manager is able to track or to realize certain customer information by clicking on the current meter reading for a particular customer. It will be identified the place where she or he is located, and on clicking on a particular customer, we shall, a utility manager can identify a particular information. We'll see that that particular name customer is registered and this customer meter number is that one, and the payment status, meter started, and other more information can be realized here. From the data collection form that have been collecting various information concerning the customers will be realized here now, the dashboard, so that they can answer and see what are the complete requests and the services are needed. So the survey form 1 to 3 have been integrated here with the dashboard so that the answers that will be returned by the customers can be elevated here and solved here. Without more further delay, let me proceed the working interface. Yes, now here the water billing system that shows how billing a customer will utilize his services. Let me log out.
Sorry, Donatus, you cannot see the interface. We are sharing the screen.
Okay. I think here everyone is able to see the screen now.
Yep, correct. Proceed.
Okay, perfect. Okay, and now the interfacing for somebody to make registration whenever he or she is in need of accessing the certain water services. We will start registering by first name, Dick, last name, gmail.com. Then I will assign my password. Then I'll make confirmation on it. Then I'll make registration. So cute. So last bit. Then the customer will log into the system. After the system will direct him to the dashboard. Welcome your dashboard, welcome, hello Deacon here. So a particular customer is able to view the billing. Now after on the spot, he has made the registration now here. There's no any billing information. So he has to be assigned the monthly payment bill, the year that is supposed to use, and the amount and the payment number that is supposed to do. On the other hand, in order so that his information to be utilized by utility managers, I will also act myself as a utility managers. I will log in again by using the admin account. My admin account is water@gmail.com. Once I've logged in, I'll be able to trace back the registration of the particular customer that he has registered. So I'll create a bill, and the bill that I will assign is for Dick Nia, the one who has registered. Also, I will assign the monthly payment. For instance, today is September 26th, 2024. And also I will assign the unit for the meter that has used the set.33 for the demonstration. I will create next. Here on the list, it shows the rest of the customers and their status, whether they have paid or not. Some donators has already paid, some have not paid, someone have pending. Now, in the case of Nai, we can see his status is not paid. On the spot, because this goes on the spot, I would like those as Nai. Whenever I log, will come now, such customer will log in, he will find his or her bill already assigned. We can see before it was empty, but now he has already assigned his billing payment. He said that is for the 8,000 Tanzanian shillings, and they're supposed to pay in such number. So the action that now will take is to pay. On the right side, the action, you click on paying, then you write the verification method. The payment, then he upload, making the payment here. Have to upload the payment status or screenshot the message that will be given for demonstration. I will upload that. Then the action will be on pending. On the spot, me as the admin server in your data company, I will see the action of NAI on September 2024 for 48,000 Tanzanian shillings that is pending. I have to take an action of making approve or not approve. So I will approve. On approving the payment for that particular, it will be shown that he has already made the payment. Now, on viewing his bill status, it will show him that he has now made the payment. And that was a brief description that shows how effective billing and the payment solution is utilized. On concluding, the act of utilizing GIS in being a payment solution, it has been a strategy that equips for water utilities that tools necessary to address current challenges while preparing for the future demands. That we can see, have to educate on the customers on how they can be able to read well their meter number. And also we have to take action of control of the water utility companies. Have to take the control on how to strengthen their system so that can ensure that there is no any leakage or any intervention that concern with the customers. And this will have given me to the end of my presentation. I would like to welcome Simbo Governor from Kenya. Simbo, welcome. Your floor is yours.
Thank you, Donatus. I'll start with sharing my screen. Yeah, I'm Kimball Gavane, who pursued a bachelor's in mathematics and computer science, majoring on statistics from Taita Taveta University. I'm passionate about data science, computer vision, machine learning, and also solutions. I had a great internship experience here at ESRI East Africa, where I was able to analyze data while working on GIS solutions and widening my scope of thinking on spatial analysis. My project is about the ACTIS for public health inspection management. This is where we'll focus on restaurants inspection as part of the mandate of the public health department in Kenya. We'll start with mentioning the Public Health Agency's function, which is disease prevention and control. This involves the implementing of strategies to mitigate the impact of communicable and non-communicable diseases throughout the various programs that the public health usually carry out, such as vaccination and surveillance. Public health policy development. This is made possible in the public health department through the formulation of policies that guide the public health practices to ensure effective public health care delivered through their systems. Research and data management, which is made possible through the continuous research on the health trends that are currently undergoing in a country and the challenges that they may face, which enable the need for the data management system to be established to monitor the health indicators and inform better decision making from a public health perspective. Environmental health as one of their functions, which includes the insurance of safe water supply, proper sanitation, and waste management, and controlling the environmental hazards, which may be a hindrance to the public health. Community health services as one of the another key functions, which focuses on the deliverance of healthcare services at the community level, thereby promoting the health education and engaging the communities in their health initiatives. Another of their function is emergency preparedness and response, which enables them to develop the strategies to respond to public health emergencies such as outbreaks, and other natural disasters, which are critical for safeguarding a nation's health. The following are the mission and the vision of the Public Health Department. The mission is enhancing the public health and the well-being of Kenyan population through the comprehensive strategies and collaborative efforts. This mission enables us to emphasize on the importance of multi-sectoral approach through the achievement of better healthcare outcomes. The vision is about aspiring to create a healthy and a productive nation where all citizens have access to quality healthcare services. This enables us to reflect a commitment to ensuring that healthcare, number one, is available and is accessible to all and equitable to all Kenyans, regardless of wherever they come from. We have the enablance of ACGIS to supporting the above functions that we already stated from the environmental health and the emergency responses. We have ACGIS as a solution to be able to map and visualize, to be able to carry out the functions of data management from the data cleaning and also the data engineering, so that we may be able to provide and safeguard the critical data of the Kenyan population, from the field mobility to the monitoring to the analytics to the design and planning, to enable us to facilitate the decision support, and to the constituent engagement, and then lastly for the sharing and collaboration, so as to make more informed decisions on their function as the public health department. Here is where we discuss the ACTIS system as a whole and its various components to be able to understand with each element and their specific roles. We have the ACTIS Online, which is responsible for the data sharing and the data collection. We have the ACTIS Pro, which is responsible for the data management. And we have the ACTIS Field Maps, which is a map-centric data collection item. We have an ACTIS Survey 123, which is a form-centric data collection form. We have the ACTIS dashboards. This is where there's executive access to be able to make informed decisions through our dashboards. This is a typical form of the food establishment inspection report. You may be able to see it's all paper-based, and you can imagine filling this whole 1 to 54 question survey can be quite tiresome, being it is a paper-based inspection. It ranges from the classification of foodborne illnesses and risk factors and the public health interventions to the good retail practices, which provide the metrics under which they may be able to they may be able to outsource an inspection score, whether one is in compliance or out of compliance, and the compliance rates of each restaurants. GIS in supporting the public health inspection workflows. A GIS, so it provides a GIS solution for automating the collection, the storage, analysis, and the visualization of spatial data management at various stages of the public health inspection on restaurants. What does it aim to achieve, or what does it make it different from the paper-based? It includes the restaurant location. The ACTIS incorporates the operational status of the restaurant. The ACTIS also incorporates the frequent health violations that may be possible. It incorporates the foodborne illnesses outbreaks, and it incorporates the restaurant compliance rates and types of violations. when we talk about the problem statement, what makes ArcGIS different from the paper-based approach for inspection on the restaurants? We may be able to find out that the paper-based inspection form may be lead to slow data collection and integration and processing. It may be able to lack that the spatial data is not linked to the attributes data. You may be able to find out that there is a duplication of efforts by individuals or departments. You may be able to find that 2 or more public health officers may be able to be in a certain geographical area without knowing, since they are following certain types of restaurants. Rework in case of lost data. This is where the paper-based inspections may not be backed up once the paper is lost. In effective data visualization tools for the decision support, this may be able to make that the ones who having the executive access from the public health department at the county level may be able to make informed decisions from the insights they may be able to get from the interactive dashboards. They may be able to gain more insights and more findings based on those key metrics that they may be looking for. Public health inspections, ArcGIS values proposition. One of the value propositions will be the detection of potential problems faster with prioritized inspections. This may be enabled by ArcGIS through the identification of high-risk establishments through the spatial analysis, allowing the inspectors to prioritize visit based on their historical data of their health violations and food illness outbreaks. The second one will be the real-time insights into the field operation. This may be made possible by utilizing the real-time data capabilities of ArcGIS to provide the immediate insights into the field operations. And the inspectors may be able to access the up-to-date information on their restaurant compliance rates, their operational status, enabling them to make and informed decisions much more quickly. Increase the flexibility to respond to the emerging problems. The system may provide the ability to process and visualize the data in real time, allowing public health officials to adapt quickly to the new changes and challenges that they may find, such as the sudden outbreaks or changes in the compliance rates, which facilitates the effective emergency response and proactive management of the public health risks. The fourth one will be the increased operational efficiency, which enables the public health officials to complete the more operations in less time as compared to the ones in the paper-based type of a system of collection. The fourth one will be the optimal resource allocation, which is brought forth through the improved data management and the operational efficiency. You can be able to conserve the valuable resources and minimizing the efforts that will be required by 2 or more public health officials will be only done by one of them. And lastly will be the automation of data collection, storage, processing, analysis, and dissemination, stock visualization, and general data management. You may be able to find that ArcGIS automates the various aspects of data management from the collection all through to the visualization, which reduces the amount of human error that may occur, which is prone to happen in the paper-based types of inspections. Here we have a holistic approach to how ArcGIS is supporting the restaurant inspection, all the way from the planning, where we use the location to plan and assign the field activities, and where we'll be able to use ArcGIS Navigate to be able to route to your work using your roads, your GIS data, even while offline. We'll be able to have an understanding through the ArcGIS field maps, where you'll be able to see what's happening with your maps. It will facilitate the capture of the data through the survey 123 and the field maps, which will be able to perform the data collection and send it back to the office from anywhere. Through the ArcGIS workforce and the dashboards, you'll be able to monitor where you'll be able to know where your workers are and see the progress of the work in real time. And also you'll be able, through the ArcGIS workforce, to coordinate, which will be able to act on real-time conditions in the field to update the workers' tasks. There are three objectives that we aim to achieve. One was to streamline the data collection and inspection workflows. This is where this whole ArcGIS system encompasses from the data collection all the way through to the visualization, enabling a smooth workflow that is not limited to human error. To facilitate information sharing and collaboration, this may be able to facilitate the inter and intra-departmental public health departments to be able to share the information and be able to share the insights that they might be able to find and see alarming, to allow the real-time access to information, monitoring, and of activities or events and multiple visualizations, which is made possible through the ArcGIS dashboards, and so that they may be able to enhance better decision making in their activities from an executive access. This is the demo. This is the ArcGIS workforce, where I have four public health officers, and there are 4 types of inspections in a public health inspection. There is the routine inspection, and there is the follow-up inspection. There are the special inspection, and there is the training and assessment. The routine inspection is the one that is conducted from a yearly basis, where they check on their compliance rates and to be able to check on their violations that they may be able to do in the recent years. A follow-up inspection is whereby we may be able to, after a possible violation by a particular restaurant, the public health officer is able to set a timeline, for example, like 3 weeks, whereby they'll come to revisit the violation, whether the restaurant improved on the violations or is still conducting the same violations. The special investigation occurs when there is special events such as outbreaks and natural disasters, where I need some higher priority to be able to fast track such a calamity when it occurs. From the training and assessment, this is where it happens periodically, where the public health department sets up workshops and to be able to put the restaurant owners up to date with the recent and the new policies in the public health sector that might have been they might not have been abreast to. So from this ArcGIS workforce may be able to notify, let's pick this for an example. My public health officer is called Paul Thomas, and I assigned him a routine inspection at English Point Residence, which is located in Nyali, and its priority, it's medium. And the routine inspection, it was supposed to be scheduled for September 28th. And upon receiving such prompt from the ACTIS workforce, my public health officer will be required to click on this field maps link where, let me share my screen. Yeah, from my phone, I will access the field maps. I'll click on the field inspection and food restaurant inspection, and you'll be able to pick like Sabakiba for as an example. You may be able to see that for Sabakiba, there is no last inspection date. You may be able to find that maybe it's a new restaurant that has been formed, or they have been evading the recent inspections. So you might start an inspection on them. You may be able to see the time is automated. The survey time, 12:49. Purpose of the inspection, it's a routine inspection. Phone number 71850. Establishment type, whether it has less than 50 seats, 50 or more cashiers, or register. Let's pick register. The number of visits it occurs per day, 1 to 1. This is a note for our public health officer. This is where it says circle the designated compliance rate, whether when it's in stands for in compliance, out stands for not in compliance, NO stands for not observed, and NA stands for not applicable. We might see the required questions from the supervision. When person in charge present or not, he was present. Employees' health, how was the management awareness? It was in compliance. Proper use or reporting and restriction. When you might choose on the good hygienic practices. For example, when you choose on out of compliance, you see it prompts two other prompts such as COS. COS stands for corrected on site, which means that when you spotted such a violation, the owner of the restaurant was able to correct it while you were there. So we put a placeholder, you say yes, and repeated violation, and then no discharge from the eyes, in compliance. We go to preventing contamination by hands. Were the hands clean and properly washed? In compliance. No bare contact with the food? In compliance. Adequate hand washing facilities supplied? In compliance. Then we may go down. Basing on the violations that were conducted, you may be able, as a public health officer, to determine whether it requires a follow-up meeting. You say yes, and schedule a follow-up meeting. For example, it's 2 weeks from now. We choose Thursday, 10th October at 12:51. At 12:51. Then timeout, it's automated. Then we click submit. Yes, you can see that it's submitted with all the necessary information that we may need from the routine, the number of seats, the number of visits, whether they were in compliance or not, all the required fields when a routine inspection is conducted are properly checked out. Mr. Share. Yeah, back to the story map. The next element we'll talk about is the survey 123 form, which is embedded. You may be able to see the key metrics that the public health department may be able to want to achieve in their normal day-to-day inspections, whether it's routine, whether it's complaint-based, whether it's special, or whether it's a training and assessment that they're conducting. You may be able to input the establishment name, let's say Upper Hill Restaurant, full address, their address, city, county, permit number, the purpose of the inspection, as we talked about, whether it was routine, special, establishment type based on their number of seats and their orientation, and their risk category, whether basing on their number of visits they usually get, and other metrics that they may be able to find. Once you have ticked all the necessary required questions, you'll go and submit the findings basing, and whether there was a violation, you'll be able to drop the images here to be able to give you a proper feedback on the next time. And lastly, we'll talk about the restaurant dashboard. This is our demo dashboard, what we aim to achieve with it. You may be able to see that there is an inspection score, the last inspection date, and their status. We may be able to give them a grade from A to F, basing on how their compliance score may be able to pan out. We may be able to set a metric such as 80 and above. We give him an A. B ranges from a 70 to a 79. And on that descending order, we may be able to feature what we may be able to highlight in that intended output. For example, in this, you may be able to see that the seats are less than 50. Yeah, this facility was inspected 1,306 days ago, and its inspection score was an 81%. Yeah. On that, I would like to conclude saying that this enables geo-enabled approach, showing its mighty strengths on how it beats the paper-based system and be able to encompasses all the necessary features that may be able to be needed from the collection to the visualization. I will end there with inviting our able quantity surveyor, Kaltuma Swara.
Thank you for that, Kimball. I'll be sharing my screen. Hello, everyone. My name is Kaltuma Sora, a final year student at the Technical University of Kenya. Hello, everyone. My name is Kaltuma Sora, a final year student from the Technical University of Kenya, currently pursuing a degree in urban planning and design. I'm grateful to have been part of the ESRI Eastern Africa internship program, where I've gained hands-on experiences using the ArcGIS softwares. The internship has equipped me with the practical skills in geospatial technologies, which I'll definitely use in my profession and also in the coming years. I'm passionate about designing and making the world a better place. Being an urban designer, so that the residents can live in there by providing dynamic solutions to our cities. So my project is about smart city design using ArcGIS, and my case study, it's a case study of Nairobi City. So I'll be explaining the planning process. The planning process involves mainly the pre-planning and community diagnosis, which implements engaging with the communities, the different stakeholders, the planning department, urban designers, all the stakeholders included in the planning department, pre-plan and engage the communities. After that, we engage in the data collection and analysis, the area that we want to develop. We collect the data sets, everything, the population, the transport, and then there's the issue identification. What are we planning to design? What do we want to improve? What's the current condition of the place we are trying to improve, and what are the future improvements that we want to engage in. Then the goals and objective formulation, where we'll be formulating our goals, our objectives, and what we want to gain. Then strategy formulation, whatever we've come up with, the goals and the objectives, we then formulate to the different stakeholders. And then the plan review and approval, where the plan is reviewed by different stakeholders, the different planning departments, after which it's then implemented. After the implementation of the program, of the plan, some plans have different scopes. Some have 5 to 10 years, some have a short period for maybe 3 months. So the plan is then, after implementation, it's then monitored and assessment, and the plan is achieved. So for the planning, we want to know what we are analyzing. Where is our community now? How do you want to get there? What do you want to envision? Where we want to be? How do we get to the planning part? And then what progress we'll be making towards reaching our goals. So I'm doing a case study of Nairobi City, and I chose Nairobi City because Nairobi CBD is a rapidly growing urban area facing issues such as traffic congestion, inadequate infrastructure, and environmental stress. This project will seek to explore solutions to these challenges through smart, data-driven urban design, identification, and assessment. For the introduction part, I'll be explaining what a smart city is. And a smart city is majorly an urban area that uses advanced technologies, including the Internet of Things, data analytics, and geospatial tools to manage resources more efficiently and improve the quality of life of the residents. Features of a smart city include sustainability, and these where the city will provide sustainable environments, urban environments to its residents by incorporating green infrastructure, having enough green infrastructures for sustainable city, enhanced connectivity, where there are improved transport sectors using different transportation systems like a bus rapid transit to develop and enhance connectivity for the city, improve public services, where will be where a smart city should have diverse and dynamic public services which can be used by the residents. So my problem statement is that the rapid urbanization of modern cities has majorly led to challenges such as traffic congestion, inefficient resource management, inadequate housing, and environmental degradation. So to address this, there's need to leverage this technology for enhanced urban planning. The objectives, for my main objective, I'm focusing on enhancing urban sustainability and promoting eco-friendly transportation by improving the integration of ECVs and green urban environments. For the specific objectives, have enhancing urban green spaces for sustainability, and then encouraging multimodal transportation. Methodologies mostly include what do we have currently, and what do we want to do, and how do we get there. So for the first step, it's needs assessment and stakeholder analysis. What you want to do, what you want to gain, the different stakeholders, the planning department, and the community at large, the public participatory planning, all those. Then after that, we'll be going to the data collection and management, where we will be having different data sets for the population, for transport, the environment, the current existing infrastructures, and then mapping them. After that, we'll be having urban planning and zoning. We map out the existing conditions that we have in the city, and then plan for the future scenarios. Monitoring, and then we have a monitoring, evaluation, and continuous improvement of the project or the plan. Then there's the solution architecturing. For the solution architecturing, I have I start with the data collections. And from the data collection, there are agencies like Nairobi County Government, Kenya Urban Rural Authority, Kenya National Bureau of Statistics, whereby we collect data sets from Nairobi County Government to discuss, or maybe to inform us about the existing existing infrastructure, existing conditions of Nairobi City. Kura will provide data sets for the existing transport network, the conditions of the roads we have, the types of roads, whether it's major roads, minor roads, type A roads, type B roads, those type of data. Kenya National Bureau of Statistics will provide data for the population of the area, majorly Nairobi and also the CBD. After collecting the data and conducting the surveys, field data management, then the data will be exported to the planning department portal using ArcGIS Online, through which the ArcGIS Online content and services, the server, will then be provided to the desktop ArcGIS Pro, through the web, and then through the device, through the devices. It's for the public access, where it involves educating and creating awareness for the public. We're telling the public this is the plan we want to do, the aims of the plan, and then we also create feedback from them using the survey 1, 2, 3. From the web, there's the planning, decision support and administration policy. The stakeholders, the planning department can use the information there for the planning process. The desktop also, there's the professional GIS users, which include which will be including recording, data retrieval, and then planning. Then after which there will be the data analysis, which includes research, spatial analysis, and integration with existing databases and business systems. There's also the part of access and sharing, which will include, it's majorly about the ArcGIS Online for the sharing parts. After my solution architecture, I'll be providing the benefits of the solution. So my plan or project for the smart city design will provide enhanced public transport accessibility. I'm trying to solve the issues of traffic congestion, the pedestrian vehicular conflict within Nairobi City. So after getting to this plan, after achieving the visions and the goals of the project, I'll be solving the congestion and enhancing public transport accessibility. I'll be improving the traffic flow and efficiency. There will be reduced or maybe none congestion within Nairobi CBD. Reducing carbon footprints and air pollution. This will be done majorly by promoting electric charging systems for the city and for the cars, so as to reduce carbon footprints and air pollution. The tools I've used are the ArcGIS dashboards, which is mostly used for creating interactive visualizations of land uses within the city. ArcGIS Pro for 3D mapping and data analysis, where this includes majorly digitizing of existing data sets such as buildings, roads, the vegetations, the different, maybe let's say walkways, the minor roads. I used the ArcGIS Pro for doing that, and then mapping, extruding it so to make it the 3D. And then analyze for the data analysis. Survey 123 helped me in gathering feedback from stakeholders and residents to know their opinions and views on the plan and the current conditions and the current lifestyle that they're experiencing within the city. Now for my contextual map, I'm focusing on Kenya, and that's the map of Kenya, and my part is Nairobi CBD, but majorly I'm focusing on the part between Uhuru Highway, Haile Selassie Avenue, Moi Avenue, and City Hallway, given that that's majorly the area within the CBD that has traffic congestions, and I'm focusing on providing solutions for the transport and also sustainability within the city. After gathering the data and having developed the data sets and everything, I then design a base map within the selected boundary or within my part of focus. And this is the base map of the Nairobi CBD that I've done. So it majorly includes the Nairobi CBD is a commercially based area, and it serves as the base map serves as the base reference for positioning, displaying, and analyzing different elements like the roads, major roads, the buildings, vegetation, and infrastructure. And this base map will allow me to overlay more detailed information like land uses, patterns, transportation networks, and urban infrastructure, providing comprehensive view of the city's layout. So this is how I analyzed the base map. So I digitized the existing infrastructures within Nairobi CBD. The base map is overlaid with the land uses in Nairobi. So the other features apart from the boundary part are the Nairobi land uses systems within Nairobi, within the entire region of Nairobi. So after digitizing every data sets within the within my boundary, then I created this the attribute tables for different land uses. Like this one, it's a neighborhood park, and the facilities, it's playground, fitness stations, and the accessibility features within the area are ramps, and then tactile pads. Then I also now proposed because it's majorly the city is it's majorly commercially based, and I want to make the city and design it to be an all-round area. I created mixed use areas for then created some residential areas, which includes so as to make the city a mixed use area where the residents won't have to go far away from to do their businesses and go home later in the evening, maybe experiencing traffic flows. Mixed use services have also, for sustainability purposes, created different vegetation areas, different parks. This shows the type of trees, the number, and the information. So after creating this, the existing land uses and proposing different scenarios like the schools, like the libraries, residential areas, different car parks, to include so the residents within CBD will not have to tire going out to park their cars. So this shows different car parks and shows the surface type as well. Capacity of the car park is 150, and the last inspection date it shows, and then the payment status, whether it is metered or whether the car park area is free. After digitizing everything, then I created an extruded building, extruded 3D buildings, which converts my 2D footprints into 3D shapes, like by adding different values, which creates a realistic 3-dimensional view of the urban landscape. And this will enable planners and city officials visualize how buildings interact with the surrounding environments, making it easier to analyze building density, height restrictions, and different sun exposures. From the base map, now I have the proposed path development part. I'm focusing on transport and sustainability part for my city. So I created different multimodal transportation areas. To reduce the carbon footprints and encouraging the residents within the area to use maybe bike lanes, EV areas, electric charging vehicles. I created the bike lanes for the residents, also the electric bike stations, which will enable residents have dedicated or shared types of bikes. So this station shows the Nairobi Central Station, which has the capacity of bikes 35. The available bikes shall be 15, and the status of the station is active, and the type of bikes is the electric bikes. This aims in reducing different public transport sectors to reduce the carbon footprint within the area. Also analyze the transport sectors and the congestion areas with heat maps. The area shows heat map along Moi Avenue, and the time of day where the traffic congestion is high is evening, and the congestion level is around 4%. So the proposed part development part map aims to provide the city with multimodal transportation systems so as to reduce people using different public transport systems, and also reducing the carbon footprint within the area. I then created the survey 123, which is to gather public input on transportation, walkability, and green spaces in Nairobi as part of a smart city design project. And this feedback will help shape a more sustainable and efficient urban feature for Nairobi CBD. So maybe for the first question, what is your primary mode of transport? The residents might answer it's a car. What transport challenges do you face in Nairobi? Maybe limited public transport options, rate the walkability of your neighborhood. So there are also important asterisks of the questions, like how important are green spaces to you in urban areas, gathering feedback from the residents. So this will help us design a more sustainable, after filling the survey 123, the residents can then submit it. Then I created the land use dashboards. Land uses dashboards to enable it will be used by the different planners and city planners so as to know the type of land uses in the area, the currents and the maybe undeveloped areas of the land. The land use management system. This will enable the residents to know the parking spaces within the area. So like this parking space, it's 150 capacity. It's the capacity and also the percentage of cars it can hold. This will be used by the public majorly to know whether the different car parking areas are free to use or they'll be full for the time beings. Then the land uses and zoning will be used by the planning department to know the existing conditions of the land uses, the educational areas, whether the null majorly it's undeveloped land, which is 7.84% mixed uses, which includes the residential, commercial, and educational. The public purposes will they can see it's around 27.4%. Then the area is covered by majorly commercial, which is 52.94%. Then the IoT sensors is the type of sensors which the residents can access and to make it a smart city. The different type of sensors, the environmental, the noise sensors, the pedestrian, to know the population density of the residents within the city. The security sensors to enable the security areas or this like the traffic lights that are available in the city will enable whether it's working or not. Smart utilities majorly for the water availability areas, and then the traffic sensor types is embedded on the traffic to enable one to know the type of the sensors, whether it's working or whether the traffic system, the status of the traffic system, whether it's two-phase, three-phase, such types. So in conclusion, I know that the smart city projects demonstrate the power of geospatial technology in addressing urban challenges. So by integrating land use data, transport network, and smart infrastructure through platforms like the ArcGIS Pro and dashboards, we can create more efficient and sustainable cities. Thank you so much. That's the end of my presentation. I'll give it back to Victor.